if two routers are not directly connected?
No, sir.
Yes, sir, we can configure. Yes, sir, we
Yes,
can.
we can.
If there is a route, we can configure.
Yes.
The route should be there. Reachability should be there.
All the routers should be reachable from each other.
It is
Then we
possible.
can. Yes, sir, it is possible via indirect neighborship.
Here we will use BGP some scenario where we need
ISP network.
Running a larger
Sir, between two A
or ISP.
between two
We have
different AS.
two different
Between
ISP.
two or
And
more,
to connect
ISPs.
the two customer sites. And if the prefix is in more than 1,000 or in lakhs, then we have to use the BGP.
a service provider network between C to P, between two companies network, and after that we had seen some types of customer network. Single
Yes,
homed,
correct.
dual homed, single multi-homed, dual multi-homed. Right? So except single homed customer, when we have single edge router and single ISP, in all the rest, all the scenario should have BGP configuration. Correct? Between two autonomous system number, also we have to configure BGP only. Now guys, if I have two router here, let's revise the last class first.
It's a general reminder for recording.
I have two router 1, router 2, both are directly connected. R2 on router number 1 IP address is 12.1. Ajay, are you there? The class. Out of
Yes, sir.
so here let's say I have enabled BGP on both router 1 and router 2. I said neighbor 12.2 on router number 1 and neighbor 12.1 on router number. So what will be the first message?
Synchronization message.
Right, so always keep in mind this point, right? Not open message of BGP. First message is going to be SYN message, right? And here destination port is going to be 170. SYN. Router 2 is also going to send their SYN plus ACK. And after that finally router 1 is going to send ACK. Then we'll have TCP connection, and our TCP connection BGP will send their messages. And first message is hello message. What is the use of hello message in BGP? Hello message is called open message, by the way. What is the use of open message?
Establish leadership.
Discover the
Neighbor.
to discover neighbor, right? And after that in message. Okay. Then we have different types of messages. We'll see those all types of messages. So one router is going to use random port number. Router 1 is using, let's say, port number 1025, and router 2 is using port number 179. Right? So both routers are going to maintain one table called TCP table. Right? There will be information about IP address and port number. Right? So you can verify it in GNS3. Let me open the GNS3 for you. Verify it. The TCP EJ2 R1. Guys, can anyone tell me, is there any port number by default enabled on router? Is any
Yes,
port
sir. There
number
is an
enabled?
one port number is enabled. Telnet.
One, yeah, telnet port, alright. And when we will enable the BGP, that means we are enabling port number 179 on the by default telnet is enabled. Only one port number is enabled on Cisco iOS router. That is 170. Sorry, port number of telnet 20. How to verify that? Here is one command to verify that. So control plane, then host open port. Right, so you can see this port number is. So this is first step of BGP verification. We should check the port number 179 is enabled on both routers or not. If there is no neighborship, if there is issue with BGP neighborship, first of all we are going to verify the port number. Port number must be 0/0 no shut, IP address 12.1.1.1 255.255.255.0 exit, and router 2 config 3 interface F0/0 no shut address 12.1.1.2 255.255.255. Let me check the connectivity. Ping 12.1.1.2. Ping is working. Yes, ping is working. Yes or no? Why is yes?
Yes.
So now let's configure BGP here. And before enabling the BGP, I'm going to capture the link. Capture the link. Okay. And now let me enable BGP here. Go to router 1. Say router BGP AS number 100. Let's say I'm going to configure EBGP. AS number 100 on router number 1. Here IP is 12.1.1. Here IP is 12.1.2. AS number on router number 1 is 100. And AS number on router number 2 is. I'm going to configure EB. Router BGP 100 and neighbor 12.1.1.2. Remote AS of neighbor is. Go to router. And before enabling BGP on router number 2, let me show you the capturing. In the capturing, are you able to see any SYN message?
No.
Why
No,
router 1
sir.
is not sending SYN message to their neighbor to 12.2? Right. One more thing here you can verify. So control plane, host open port number, and you can see now two TCP port numbers are enabled here. One telnet and another one is BGP 23
It's
and
in
17.
listen to.
Hmm?
Nothing, sir.
Sir, 179 will enable automatically, right? When we configure BGP.
Yes, yes.
Okay, okay.
It should be done on a random port, right? Initial SYN packet. So
Source port
23 is
number
for
will be the
telnet.
random port number.
Yes, that's what.
Are you able to see now SYN message? In the SYN
No.
message, source IP is
Yes.
12.1,
Yes.
destination IP 12.2. Source port number is random port number, destination port number is 179. Means which router is going to use 179 port number, well known port number of BGP?
R2.
R2 is going to use well known port number of BGP. Okay. Apart from this, you can open the SYN message to check the information. Right, same information will be there, whatever information we have under TCP. Then router 2 is sending which message? Reset message and acknowledgement message. Why, guys? Because you
Because
know
port is not open
port is not
on
open,
the
and
router.
whenever port is not open, router will send reset message. So let's enable BGP on router number 2 also now. Router BGP yes number 200, and here say neighbor 12.1.1 and remote yes of neighbor is 100. Now router 2 is also going to send SYN message. This is SYN message of router 1. Soon we'll have SYN message of router 2. Router 2 reset message. Now you can see the open message of BGP. And before the open message, here is the SYN message of router 1, SYN message of router 2. In the SYN message of router 2, source port number is 179, well-known port number of BGP. And destination port number is 31445. This is, guys, final port number of router number 1. Now router 1 is going to use this port number on. In the BGP open message, if you will open BGP open message, you can see in the TCP header, source port number is 31445. Right? So for entire BGP session, router 1 will be using this port number, router 2 will be using 179. After that, open message is there, keep alive message is there, right? And here we have one log message of BGP neighborship also. Neighbor 12.1.1 is up. On router number 1, also we have similar log message, neighbor 12.2 up. So TCP brief. First of all, let me show you the TCP connection here. You can see we have TCP connection between 12.1, who is using this port number 31445, and foreign address is 12.2, port number is 179, state is established. And so IPBGP summary. Okay, so who is neighbor? 12.1.1.2, version of BGP 4, ES number of neighbor 200, right? How many message it have sent to this neighbor? 4. How many message it have received from this neighbor? 4. Repeat for now. Uptime till when this neighbor is up, and prefix received from this particular neighbor is 0. So this router have not received any prefix from this. So this is basic lab of BGP, which we have already covered in last class. Here you only need to verify what port number router 1 is using, what random port number router 1 is using, and then you can check the BGP neighborship. After forming the BGP neighborship, we are going to advertise the prefixes. Let's say here on router number 1, if I have one subnet 10.1.1.0/24, and on router number 2 I have subnet 20.1.1.0/24. Similar like OSPF, now we can advertise these prefixes in BGP protocol. For now, if I will show you the BGP table of router 1, so IP BGP, this is similar like topology table of EBGP or database table of OSPF. In the same way, BGP maintain database called BGP table, and you can see there is no any network available, no any prefix available. Then in BGP, we called prefixes to NLRI, network layer reachability information. Okay, so there is nothing in the BGP table because we have not advertised any prefix. Now guys, one thing here, router BGP is number 100 and network 10 dot. Before that, let me create the loopback interface, loopback 1, and IP address 10.1.1.1.255.255.255.0. okay, router BGP is number 100 and network 10.0.0.0 mask 255.0.0.0. Will this command advertise my loopback network in BGP? What do you think? Will this command advertise 10.1.1.0 in BGP? Answer of this question is
No, sir.
why? Why no? But in case of OSPF or EBGP, definitely it will advertise. In case of OSPF or EBGP, definitely it will advertise in routing protocol, but in BGP, so IP, BGP, you can see.
So because it is the class full routing protocol.
So this class full means I can make it class less 10 dot 1, and here I am going to make it 255.0.0. 255.255.0 router, right? Again you can check BGP table, so IP BGP. Guys, tell me one thing, if router 1 is connected to another router, let's say R0, okay, and here we are running OSPF routing protocol, or let's say we are running EBGP protocol here, EBGP, and here we are running OSPF, right? And here I have one loopback 10.1.1.0/24. So router 1 is going to learn 10.1.1.0/24 through EBGP. Router 1 will have this route in their topology table as well as in their routing table, correct?
Correct.
If I want to advertise this 10 subnet into OSPF, can I advertise it through network command?
No,
No, right?
No,
Here I
then
have to perform redistribution. I have to run
indoor
redistribute
is
command.
distributed.
Right? Only redistribution will work. But again, there is some difference in case of in BGP. If route is available in the routing table, then you can advertise it through network command. Right? The requirement of advertising route in BGP. By the way, we have one topic. This is one topic. How to advertise prefixes in BGP. We have multiple ways. We will discuss all. But for now, what you need to keep in mind, you can only advertise those prefixes in BGP through network command which are available in the routing table with same subnet mask. Which are available in the routing table with same subnet mask. So here you can see I have advertised this subnet 10.1.0.0 with subnet mask what? Is this route available in the routing table? No. Is this subnet available in the routing table? No. In the routing table means in the local routing table. In the local routing table, same network must be there with same subnet mask. Then only BGP will advertise that. So IP route. In routing table, in the global routing table, you can see we have subnet 10.1.1.0/24 directly connected on loopback 1. And guys, what is slash value? Subnet mask 24. So we can advertise this subnet with same subnet mask 255.255.255.0 only in BGP. Router BGP case number 100 and do so run section BGP. And I'm going to remove this network command first. Now I have only neighbor command here. You can work. Now if you want to advertise 10 networks, here you have to run command 10.1.1.0. Network should be same and mask should be also same. If this subnet with this subnet mask is available in the global routing table, then only BGP will install it in their BGP table. Right? Now hit enter and now let me show you the BGP table. So IP. Now you can see it have installed this subnet in BGP table. Yes or no?
Yes, sir, it's correct.
Next hop 0.0.0 means it is self-advertised prefix. And these are the attributes, BGP attributes. With
Sir, here I
local
lost.
preference, metric. 1 minute. Yes. Karthik.
Yes, sir. So, sir, yes, sir. Here BGP, just we are going to advertise the routes that what we have only. It's not going to activate BGP on that interface, not same like OSPF and
No,
EAGR,
no,
right, sir?
not like that. Yes.
Uh,
The
okay.
network with same subnet mask must be there in the global routing table. Then only BGP can install it in the route in their BGP table. And when router will install it in BGP table, then definitely it will share this prefix to their neighbor. So now router 1 is going to create one BGP update message and it will share to their neighbor. So now on router number 2, if you will check neighbor table, so IP BGP summary. So here also you can see receive route from this neighbor 12.1.1 is 1. So this time it is receiving one route from their neighbor. Right? On router number 1, you can check one more command. You can run one more command. So IP BGP neighbor 12.1.1.2 and advertised route. So it will show you which route it is advertising to their neighbor. Which route it is advertising? Say 10.1.1.0/24. And guys, in the update message, what will be the source IP address? 12.1. So that will become next hop address on router number 2, similar like EBGP and OSPF. So now router 2 is also going to install 10 subnet in their BGP table. So IP BGP. Here also you can see we have same subnet. Next hop IP 12.1.1.1. Right? And now it is going to install it in the routing table also. So IP route BGP. Here also you can see route is there. AD value 20 metric 0. Next hop 1. Any question till here?
Sir, here where we can be able to find the AS number.
AS number means?
AS number to reach this network 10.1.1.
Here
Is
is
there
the AS
any?
number
Uh,
in the BGP table.
okay.
Right? If there are two AS between router 1 and router 2, you will get two AS here. Yes, 100, 200, 300
Okay.
like that.
So to reach this network, we have to go through this AS number.
Yes, we have to go through these all. Yes. Anything else? Clear guys, basic lab of BGP. In the same way on router number 2, I can advertise 20 submit router BGP, and before that I need to get loopback interface loopback 1 IP address 20.1.1.1 255.255.255.0 exit router BGP AS number 200 and network 20.1.1.0 mask 255.255.0. Will this command advertise 20 submit in BGP?
No, sir. No.
No, because network is even same, but subnet mask is different. Okay, so here I have to say 255 dot, and now so IP BGP. In the BGP table you can see we have two subnet here. One is self advertised 0.0.0, right? And this is interview question. Interviewer can ask you like on the router how I can check the self advertised prefixes in BGP. Right? There are lots of prefixes in BGP table and I want to find the self-advertised prefixes. So you can say we can filter the output over here. So IP BGP and then we can say include only 0.0.0. So it will only show me the self. Right? Right now I have only two subnet in the BGP table. That's why we can easily see, okay, this is self-advertised prefix. But guys, what I told you, when our network size is very large, then we are going to configure BGP. That means in the BGP table, we will have lots of entries. Right? So it is very important that how you are reading the output. Okay. Now we can
Sir,
ping these two LAN can now communicate with each other. Yes.
A small question, sir. Sir, I would like to ask you. Um, For generally, if two ISP means two enterprise network, big network, this one, each and every route we have to advertise manually. It will be big work. I want to know.
No, on what I told you in last class also, on each router we are not going to advertise prefixes in BGP. Right? Sometimes we need to exchange the prefixes with undirectly connected router. And we have some simple configuration router that cannot install lots of prefixes. So directly will form BGP neighborship with undirectly connected router. For an example, in the network, I have this network, router 1, router 2, router 3, router 4, router 5, and router 6. This one. Okay. R1 have lakhs of prefixes in their routing table.
Okay.
Which you need to advertise to R5. R5, R1 and R5 should have these lakhs of prefixes in the routing table. Reason can be anything. Maybe here the subnet which is connected over here on router number 1, they are going to communicate to those lakhs of prefixes. R1 also need lakhs of prefixes. So instead of advertising all the prefixes to all the router, we are going to form BGP neighborship here between router 1 and router 4 that day. Right? And between router 1 and router 5, how many paths are there? Multiple paths are there. This is also one path. This is also one path. This is also one path. Right? This is also one path. So lots of paths are there. So we'll never use physical interface IP address for BGP neighborship. We can create one loopback over here, one loopback over here. We'll advertise that loopback in IGP protocol. Let's say we are running OSPF as a IGP, just to make reachability between all the routers. Right? So here I have one loopback 1.1.1.1. Here I have loopback 5.5.5.5. So both the loopback will be reachable through OSPF. Correct? In the OSPF, we are going to advertise the loopback. Once both the loopback are reachable, my BGP neighborship will come up, and then we are going to advertise this lakhs of prefixes through BGP router number 5. This way you will be using. We will be not configuring BGP on each and every routers.
Yes, sir. This point I clear, sir. But between R1 and R5, if you want to advertise this lakhs of prefixes, means we have to enter the network command. There is too much.
No, we have multiple ways to advertise prefixes in BGP. What I told you, this is a
Yeah,
separate
yeah.
topic.
Yes, sir.
This
Okay,
is
sir.
only
Okay,
one
okay,
way.
okay, sir. Okay, okay.
Right? Or maybe, brother, router 1 is connected to another router, and here BGP is already running, and you are receiving all lakhs of prefixes through BGP. So only you need to form BGP neighborship between router 1 and router 5. Right? Now, earlier these lakhs of prefixes were required on router number 1 only. Now it is required on router number 5 also. Right? So manager told you, or your team leader told you to advertise these prefixes on router number 5 through BGP neighborship. So just configure BGP neighborship between router 1 and router 5. That's it. That can be these are the requirement of real-time network. Okay. So now you can see in the BGP table of router 1, I have both subnet, and on router number 2 also in the BGP table of router 2, we have both the subnet. Right? And in the routing table also, so IP route BGP, here I have 20 subnet, and on router number 2, so IP route BGP, here I have 10 subnet. So now these two subnet can communicate. Ping 20.1.1.1 and source 10.1.1.1.1.
Sir, can you make a loopback interface on R1 and R2 and then can we?
I will do. So IP BGP summary. Guys, is there any information about neighbor? Is IBGP internal neighbor or external neighbor? Which type of neighbor it is? Here you can do one thing. You can check what AS number is running on router number 2, and here AS number of neighbor. Then you can identify this is EBGP neighbor. And there is one more command to check the detailed information. Here you can use, I think, neighbor command. Neighbor command. Right? So see the output here. How to read this output also. Let me show you some popular thing over here. So BGP neighbor is 12.1.1.2, remote ES is 200, and link type is external link. Which type of neighbor it is? External neighbor. BGP version 4, remote router ID is 12.1.1.2. Router ID concept in BGP is exactly similar like OSPF. Manually we can configure the router ID. If we have not configured the manually, then router will look up for highest loopback. If loopback does not exist, then router will look up for highest physical interface IP address. Okay. After that, a state of neighbor is established. Uptime, last read, last write, hold on time. Hold time is 180 seconds. Keep alive time is 60 seconds. See, there was two use of hello message in OSPF or in EBGP. One is discover neighbor, and another one is keep alive. Right? In BGP, we have two separate message for both tasks. To discover the neighbor, here I have open message, and for keep alive, I have a separate keep alive message. Size of keep alive message is going to be very small. So router is keep alive message is periodic in nature. It is keep sending keep alive message after every 60 seconds, and neighbor router is going to hold that for 180 seconds. Then there is some information about neighbor capability. Okay, then messages, how many open message this router have sent to this neighbor and received to this neighbor. Receive from this neighbor one open message, send one open message, receive. How many notification messages router have sent to their neighbor 00. So these all are what types of messages of in BGP. How many types of messages are there guys in BGP? 1, 2, 3, 4, 5. Total 5 types of messages are there in BGP. You know what is the use of open message. You know what is the use of keep alive message. You also know what is the use of update message to share prefixes. Right? And we will discuss about notification message and route refresh message. So here is the detailed information about messages. How many messages it have sent to neighbor, or how many messages it have received from the neighbor, and total number of message. How many total number of messages it have sent to neighbor? 23. And how many received from the neighbor? 23. Okay. Then prefixes. Advertise prefixes information. 1. Total prefix 1. Right. So these are some information here you can check by using so IP BGP neighbor command also. Then on router number 2 also, on router number 1 also can. Then so IP BGP, and here in the BGP table the two subnets are there. If I want to check it in detail, I can say so IP BGP 10.1.1.0 and then I 55.255.2.0. So this way you can open it in detail. So this is local prefix, that's why next hop IP address is 0.0.0. Okay, router ID, fine. And even we can change the router ID manually. We can say router BGP 100 and BGP router ID here 1.1.1. On router number 2, router BGP 200, and you can say BGP router ID 2.2.2.2. So IP something. Okay, and now so IP neighbor. Here you can see the router ID of neighbor now. 12 dot. Now here is dot 2 dot. Okay. So these are some basic verification command and basic configuration of BGP. Okay.
Sir, if you enter the router ID manually, then no need to clear the same like IP OSPF process, right? No need to clear process.
Here routers are not sharing the database, na brother. In the keep alive message, routers are exchanging router ID after every 60 seconds. So we don't need to refresh. Need to clear the process. Anyone can ask you during the interview, or if you are working, your team member can ask you, can you explain the types of message and BGP? So always keep in mind, these all 5 types of message. Topic, types of messages. First one is open message. Send message is not the BGP message, right? That is TCP message. Keep alive message. Third one is update message. Fourth one is notification message. And the last one is route refresh. Okay, guys, open message, I already told you, it is used to discover. Keep alive, used to check neighbors are alive or not. Update message, update, it is used to share network information. Used to share network information, similar like OSPF update message or EBGP update message or RIP update message information. Now question is, what is notification message, Praful, here? Because notification message is the message. Okay, so guys, whenever there will be error in the BGP, or let's say there is some error, because of that router 2 is going to break the neighborship with router 1, or router 1 is going to break the neighborship to router number. So before breaking the neighborship, router is going to inform their neighbor that, hey brother, I am going to break the neighborship with you. With the reason, what is the reason? What is the cause of breaking the neighbor? Right? It will tell about the error. Right? So here we can say, when router break, router will break neighborship at that time. At that time, router will send notification message. Which message? Notification message. Or we can say router will send cause. Cause means why I am breaking the, why I am breaking neighbor. I am writing in easy language, okay, through notification. Later we'll see the notification message also. Many times while implementing BGP in the network, you will get notification message, right? You will learn about the errors, all errors. Right? For an example here, on router number 1, I said your AS number is 100 and your neighbor AS is neighbor 12.2, remote AS is 100. On router number 2, I am going to say neighbor, sorry, your AS 200 and neighbor 12.1 AS number 200. So guys, again see there is error, yes or no, in the configuration. So in the console you will get notification message over here, right? You want to see? No router BGP AS number 100. Router BGP S number 100 and BGP router ID 1.1.1 and neighbor 12.1.1.2 and remote yes. By mistaken I have configured what? 100 and then network 10.1.1.0 mask 55255.255 dot is down. So IP and here you can see the notification message. Notification message received from 12.1. They have received on router number 1 also you can see the notification message. Which type of message it is? BGP third type of message. Sent to neighbor 12.1.1.2 peer in wrong. Peer is in wrong autonomous system number. Is receiving notification message also, sending notification message also, right? So this message is used to inform the neighbor about error, about the error. How to correct it? Simply I am going to say no to this command and then I am going to say neighbor. Okay. Now if I will talk about the content, like in the open message, what will be the information? Similar informations like the hello message of OSPF or EBGP, length of message, type, which type of message it is, BGP version, then on autonomous system number, then hold on time, router ID. These are the information carried by open message. Here you can open any open message and then you can check it. Here is my open message. I can open it. What are the information? Length is there, type is there, type code is 1, open message, version of BGP, on ES number, hold on time, router ID, right, and some parameters are there. Four, okay. Right. So router 1 is supporting IPv4 neighbor, those informations are there and some basic information. In the update message, network information will be there. If I am going to open any update message over here, let me do one thing. On router number 1, I am going to again, I have BGP neighborship here, you can router BGP S number 100. I am going to remove this network command. Work. And here you can see router 1 have sent the update message. Again I am going to advertise this network information. Again router 1 will send update message. There is the update message, keep alive message.
B1 update message, 81 update message. We see it go. You have to scroll up, sir. Stop the captcha. Oh yeah.
So what information is there? NLRI, network layer reachability information. We call prefixes to NLRI in BGP. Okay. And here if you will open, you can see which prefix is there, 10.1.1.0/24, right? Prefix length and NLRI prefix. Apart from it, again we have similar information like message type, total path attribute, and here are the path attribute, right? So we will talk about these attributes later. Origin code, ES path, next hop, right, metric. We'll see these all attributes of okay. So guys, is all types of message are clear to you? Tell me.
Yes, sir. There is a route refresh message. What?
Route refresh message is nothing. Whenever we are going to refresh the BGP, there is one command here. Command is, if you want to refresh the BGP table, you can run clear IP BGP star soft in. So in this case, router is going to send one route refresh message to their neighbor to refresh the BGP table and routing table. Automatically, router is not going to send any route refresh message. Is notification message clear? Update message clear? Keep alive message clear? And open message clear? These are the very important messages. Interviewer or anyone can ask to. I will tell you about route refresh message later also. Right, when we'll use it, implement it. If it is clear, then Anjali said, sir, please configure BGP with loopback here. So let me try to configure BGP with loopback once. Config T. By the way, we have this lab in upcoming days also. No router BGP S number 100, and on router number 2, I'm going to say no router BGP S number 100. Right, and let me create one loopback on router number 1. 1.1.1.1, and on router number 2, 2.2.2. So first of all, tell me, can 1.1.1 and 2.2.2 are reachable with each other?
No.
Interface loopback
No.
10 IP address 1.1.1 255.255.255.55. On router number 2, interface loopback 10 IP address 2.2.2.2 255.255.255.55. So there is no reachability between 1.1.1 and 2.2.2. If I will ping 2.2.2.2 source 1.1.1, ping will not work. Reason route is not available. So guys, to make reachability between 1.1.1 and 2.2.2, just I am going to enable OSPF over here. I'm going to enable OSPF routing protocol. So router OSPF 1, router ID 1.1.1.1, 1.1.1, then interface range F0/0 and loopback 10 back 10, and IP OSPF network point to point IP OSPF 1 area 0. On router number 2 also router OSPF 1 and router ID 2.2.2.2, and exit interface range F0/0 and loopback 1 IP OSPF network point to point. For the faster convergence, just I have changed the network type. That's it. IP OSPF 1 area.
Loopback 10.
Sorry, here loopback 10. Extremely sorry. Interface loopback 1, no IP OSPF 1 area 0, no IP OSPF network point to point, IP OSPF network point, and face loopback 10 IP OSPF network point to point F1 area. Now I can ping, right? 1.1.1 and 2.2.2 are reachable. You can see now ping is working, success rate is 100%. So now we can configure the BGP. Okay, config T, router BGP S number 100, and I am going to say neighbor 2.2.2.2, whose remote AS is 100. And on router number 2, router BGP S number 200 and neighbor 1.1.1.1, and remote AS is 100. Will BGP neighborship come up? Will BGP neighborship come up, guys? So IP summary. You can see neighbor is idle. These are the states. Right? Later we will discuss these all states. Active, idle, right? All the states. Forwarding. But this time neighbor is idle. There is no BGP neighborship. So IP BGP. So IP BGP summary. if you want to know the reason, you can check the capturing, right? See, hello message of OSPF, ping, any message, there any message of BGP, in message,
We can
No.
filter with port 179, sir. TCP dot port equals to 179. No, TCP dot port. TCP dot
179.
TCP dot port double equals to 179. Double equals to 179.
Not sending any SYN message. Router 1 is not sending any SYN message. When router 2 is also not sending any SYN message. Yeah, I'm only hello message of OSPF. What is the so run section?
Sharp.
What is the issue is update source loopback 1. Here by default source is going to be what? 12.1.1.1. But in the capturing, I should have open message, sorry, SYN message. Don't know why we are not able to find SYN message over here in the capturing. Router 1 should send SYN message with source 12.1.1.1 destination 2.2.2.2. Right? Here we can use debug IP TCP direction. Call F maybe send SYN. Try to add one router case number 100 and neighbor 2.2.2.2 and update source to back 1.
Sir, is it loopback 1 or loopback 10?
Back 10. Router or
So can we try to ping first? Ping 2.2.2 from R1. It's working right.
it's taking time, right? Now it is just Red. Not working. Can do one thing. Router. At least if route is available, it should send the SYN. Back route 1. Face F0 that IP address 5252 IPO is F area 0 exit back 1 P address 525255 area 0 50 face F0 that IP address .1.525 dot 0 IP area 0 face back 1 IP address 5252 one area 1 ping .2.2 source 1.1
It's not pinging.
so IP in ping with
Is subnet correct for 2.2.2.2?
yeah submit.
So can we do a IPD?
Out recipe. Yeah,
Okay.
working config T router BGP number 8 and neighbor 2.2.2 OTS of neighbor is 200.
Packet.
1.1.1 of neighbor is 2 check. Full connect. Okay. So just because of connected check, I will tell you about this later. By default, guys, for EBGP directly connected check rules check means router never should be directly connected. But in my case, never is not directly connected. So that's why I have disabled this rule. Right after that, you can see router has started sending what? SYN message. But what is the source address in the SYN message? 12.1.1.
So can you repeat once again? Disable connected check. What is that?
For EBGP routers, BGP LB check connected rule means neighbor should be directly connected by default.
Okay. Okay.
Right? But my neighbor is not directly connected, so that's why I have disabled the rule. Right? In for the IBGP here, if you will configure the IBGP, even you don't need to run this command. By default, for EBGP, connected rule is enabled. Now, still we don't have neighborship. Here also, if I am going to disable the rule, neighbor 1.1.1 and disable connected check, then also you can see I don't have BGP neighborship. So IP BGP summary, neighbor is still idle. So why neighbor is idle? Here is the answer. Source IP address in the SYN message. Source IP address in the SYN message is what, guys? When router 2 is sending 12.2 and router 1 is sending 12.1. Correct? So here we need to update the source address in the SYN message, right? By running command router BGP number 100 and neighbor 2.2.2.2 update source loopback 1. Once I will run this command, automatically we'll have BGP neighborship. Right? Soon my BGP neighborship will come up. So IP BGP summary. You can see neighbor is up. Right? So this way indirectly connected or external BGP works or configure. We'll see it. We'll see, guys, indirectly connected neighborship later between 2 router or 3 router with the help of loopback. Whatever commands you need to run to disable the checksum, sometime TTL value you need to increase when you have more than 2 routers between source and destination. We'll talk about those all things later. First, let me cover one topic, that is loop avoidance mechanism of BGP. Okay. So till now we have covered the basic of BGP and basic lab of BGP. Now let's understand the loop avoidance mechanism. Loop avoidance mechanism is what if the topology is in loop, right? We need to understand loop avoidance in case of IBGP or EBGP in both. First, let's understand loop avoidance in IBGP or EBGP. Let's say I first. Right? So for an example, I have a topology like this. R1, R2, R. First of all, you tell me in case of RIP routing protocol, in case of EIGRP, how loop will not form here? What rule or mechanism is by default running for loop avoidance in case of RIP? In case of distance vector routing protocol,
There is a split horizon.
a split
Split
horizon, right?
horizon rule.
Very good. A split horizon rule. So here if I have one subnet 10.1.1.0/24, R1 is going to advertise to both the neighbor and R2 and R3 is going to advertise to again both the neighbor. But guys, if router number 3 is going to receive this subnet from R2 first on this link, then it will never advertise same subnet from the link, from the same link from the receiving interface. That is what? A split horizon, and this way loop will not form. But in case of BGP, here if I am running BGP, same AS number, R1 is going to advertise it to R2, R2 is going to advertise 10 submit to R3. What if R3 will also advertise to R1? That is what? Again,
Loop.
loop. So how BGP is going to avoid the loop? So there is one rule for IBGP. IBGP. What is the rule? rule. Do not send those prefixes to IBGP neighbor which you have received from IBGP. Do not send the prefix to IBGP neighbor which is received from other
IBGP. Other
IBGP.
IBGP.
This is the rule. So in this case, if I have three router R1, R2, and R3, and guys, if I am running BGP on all the router, same AS number R1, R2, R3. I'm running same BGP AS number, let's say 100 over here, 100 over here, and 100 over here also on router number 3 also AS number is same 100. And if R1 is advertising one subnet 10.1.1.0/24, will R3 have this subnet? According to this rule, R1 is going to advertise 10.1.1.0/24 to R2. And will R2 advertise it to R3? No, never, because R3 is their other IBGP neighbor. So it will never advertise the prefixes received from IBGP neighbor to other IBGP neighbor. So in this case, R3 will never receive this subnet 10.1.1.0/24. And how R1 and R3 are going to exchange the route? So you know, in this case,
like via OSPF we can advertise.
no, why we will then? Why I have configured the BGP here? I
Okay.
have configured BGP to advertise prefixes only. So here guys, we know our topology, physical topology is not in loop. Here loop cannot form. So manually we can break this. Manually what we can do? We have to break this. Break loop avoidance rule in these kinds of scenario. Right? But by default, always keep in mind, by default, BGP router never advertise the prefix to their IBGP which it have received from other IBGP. Okay?
Okay.
I have one question here. For BGP to happen, you said between two routers, they should first finish the TCP handshake. For finishing the TCP handshake, we need the routing, an underlay routing protocol like OSPF and BGP. So why not advertise the same network via OSPF or EIGRP?
I am running OSPF just to make reachability. And here even reachability is not required. Na? Here I am not going to form BGP neighborship with loopback. Directly I am using physical interface IP address. I am going to tell to router number 1, your neighbor is router 2. I am going to tell to
So
router
you
2.
mean you will form the neighborship between R1 and R2 and R2 and R3?
Yes.
Okay.
Here we have BGP neighborship between all the routers. On all the routers I am running BGP. Na? I am not running BGP only on router 1 and router 3. I am running BGP on all the router. So by default, R3 will not receive this 10 subnet, or if R3 is advertising any prefixes, that will be not received by router number 1 by default. You have to
But
manually
in this
break
case,
the.
how is R1 and R3? R1 and R3 are not the connected neighbors, right? They are indirectly connected. So R1 and R3, they will not form the neighbor, right?
So until
I
and
don't
unless
know.
you will
Correct
not
me if
define
I'm
the
wrong.
neighbor command, it will not form the neighbor. Here another option is there. We can form one more neighborship on router number 1. I can say neighbor router 2, neighbor router 3. We can form BGP neighborship between router 1 and router 3 also. Then definitely we'll have the
So
prefixes.
what will you have in the route entry? That's what I want to know. If you want to form the neighborship between R1 and R3, what routing entry? Just say next hop as R2, and then from R2 it will go to R3.
Whatever IP address you are going to use in the neighbor command, that IP address must be there in the routing table of router 1.
Okay.
Okay. So guys, is this loop avoidance mechanism clear in case of
Yes, sir.
IBGP? So by default here, this is a question. Like let's say here I have one network 30.1.1.0/24. So can 10 and 20 communicate by default after enabling BGP on all the router? Answer of this question is
No.
right. And we'll see how we will make reachability, how we will make communication between 10 and 30. Okay, by breaking the IBGP loop avoidance. Okay. Now let me tell you the loop avoidance in case of EBGP. Loop means in E. So what EBGP said, whenever router will share prefixes to IBGP, it will never include their ES number. What I am saying, whenever a BGP router is advertising prefixes to their IBGP neighbor, it never include their ES number. But whenever BGP advertise prefixes to their EBGP neighbor, it always include
ES number.
Right? And whenever router is going to find their own ES number in the update message, router will discard that
Message.
This is simple loop avoidance mechanism in case of EBGP. Example, here I have one router. Let's say R1, ES number 10, R2 with let's say same ES number 10, R3 ES number I am running here 20, R4 ES number here I am running let's say 30, R4 sorry R5 ES number let's say again 30, here ES number is 40, and let's say these are connected like this. Router 1 is connected to router 2 as well as router 6 this way. For an example, any topology you can design. R1, R2, R3, R4, R5. For an example here, my AS number is 10. Here my AS number is 10. Here my AS number is 20. Here my AS number is 30. Here my AS number is again 30. Same AS number. Here my AS number is for an example 30. Okay. And on router number 1, there is one network connected 10.1.1.0/. Network is directly connected to router number 1. Right. So see how loop will not form over here. How loop can form? If router 6 is going to advertise same subnet 10.1.1.0/24 to router number 1, that is loop. But let's understand how router 1 will discard the update message for 10 subnet. What will happen? When router 1 is going to advertise gets 10 subnet to router number 2, will it include ES number in the update message?
No, sir.
No, right? So 10.1.1.0/24, because it is advertising this prefix to their IBGP neighbor, so it will not include the ES number. When router 2 will advertise it to router number 3, will router 2 include the ES number?
Yes.
ES number is going to be
Mhm.
10. When router number 3 will advertise to router number 4, will it include the ES number? Yes, it is advertising
Yes, sir,
to
it will include.
EBGP. So ES number 10 was already there in the update, and it will include their own ES number also 20. When router number 4 is going to advertise 10 subnet to router number 5, will it include the ES number?
No, sir.
Right? 10 and 20 is already there. When router 5 is going to advertise to router number 6, will it include the ES number? 10 and 20 is already coming. 10 and 20 ES is already there in the update message. Will it include their own ES? Yes. It is advertising to
Yes.
their EBGP. So ES number 30 will be also included, added over here in the update message. But when router number 6 is going to advertise to router number 1, will it include the ES?
No, because the 10 is
Yes.
already there.
Yes. It is advertising to their EBGP, na? So 10,
Yes, yes.
20 and 30 is already there, and it is going to add 40 also. Now question is, will router 1 accept this update message?
No, it will not accept.
It will not accept. Why? Because it will find their own ES number in the update message. So
Correct.
whenever router is going to find their own ES number in the update message, it will discard the update. Router will see my ES number is 10 and same ES number is coming in the update message also. That means there is loop. Let me discard it. So this way we are avoiding the loop in case of EBGP. Clear? When our router receive prefix with their own ES number, then router will discard the prefix, discard the update message. This is simple rule you need to remember. Two rules are there, one for IBGP, one for EBGP. For IBGP, it is so simple that whatever prefixes you have received from your IBGP neighbor, do not advertise to other IBGP. For EBGP, we have again simple rule. Do not accept the update message where your own ES number is found. Where your own ES number is there. Yes.
Yes, sir. Sir, I have one small question here. For example, if our router number 5 R5, it has one network.
Router
So
5.
R5 it will yeah.
Okay.
Say for example router 5. R5 it will advertise to R4 also, and R5 it will advertise to R6 also.
Correct.
Then how router 1 will insert this 30 dot network into which path it will select?
Which router?
R1.
R1. So R1 is going to use attributes. For an example, when R5 is going to advertise 30 subnet to router number 4, will it include AS number? Yes. 30 AS number is there.
Yes.
When R6 will advertise to R1, it will include the AS number. So 30 and 40 AS number are there. Two number of ASA are there between source and destination. When R5 is going to advertise it to R4, will it include the AS number? No. When R4 is going
No.
to
Yes.
advertise to R3, yes, 30. When R3 is going to advertise it to R2, yes, it will include the AS number. So 20 is there and 30 is there. When R2 will advertise to R1, will it include the AS number? No. So
No.
20 and 30 is there. Same number of AS is there, right? So this is one path attribute. Here path attribute is tie. Equal number of ESs are there. Now it is going to check another attributes. It is going to check another attribute.
Okay.
So when we will discuss the attribute, you will understand the best path selection. How router is going to select the best path.
Okay.
This is one attribute. AS path is one attribute. Like this, we have so many attributes in BGP. By default, BGP does not support load balancing also. So it cannot install both the path. Now one more rule you need to learn. That is next hop rule. That is next hop rule. 4 rules are there for BGP. One, to avoid loop in case of IBGP. Second, to avoid loop in case of EBGP. Third, next hop rule in case of IBGP. 4, next hop rule in case of E. Okay. So what I am saying, next hop rule in. So what is next hop rule in EBGP, guys? For an example, I have 3 router, R1, R2 and R. EBGP means AS number is different on all the routers. R. Here AS number is 10. Here AS number is 20. Here AS number is 30. Right? Here my IP address is 12.1. Here my IP address is 12.2. Here my IP address is 23.2. And here my IP address is 23.3. So simple. And let's say one LAN is connected to router number 1. There is one LAN with subnet 10.1.1.0/20. 10.1.1.0/20. And I have advertised this network in BGP. So first of all, router 1 is going to install it in their BGP table. Right? And guys, in the BGP table, see. So IP, nothing is there. Let me create one loopback. Interface, loopback 10 IP address 10.1.1.1 255.255.255.0 exit router IP case number 100 and network 10.1.1.0 mask 255.255.255. And so IP BGP. In the BGP table, you can see these two symbols, a star and greater than sign. What is the meaning of a star? A star means it is an valid prefix. It is an valid prefix. And what is the meaning of greater than sign, guys? It is the best prefix. Right? That means this prefix is valid as well as best. And BGP only install those prefixes in their routing table which are valid and best. Soon you are going to see some prefixes in the BGP table which are only valid but not best. BGP will never install that in their BGP table. BGP like routing table. In the BGP table, even it will install the prefixes. If prefix is valid or best, that is fine. But in the routing table, only those prefixes will be installed which are valid as well as. So when I am going to advertise 10 subnet on router number 1, prefix is definitely valid as well as best. 10.1.1.0/20. For this is BGP table of router number 1. BGP table of router number 1. And next hop IP address is going to be what? 0.0.0 because it is self-advertised prefix. You know this. Am I right? After that, router 1 is going to send one update message to router number 2 to advertise this prefix. To advertise this prefix. And when router 2 is going to receive this update message, router 2 is also going to install it in their BGP table. In their BGP table, which prefix? 10.1.1.0/24. And next hop IP address is going to be 12.1.1.1. This prefix is valid as well as. Right? After that, router 2 is going to send one update message to router number 3. And router number 3 is also going to install this prefix in their BGP table. Valid, best, 10.1.1.0/24. And next hop IP address 23.1.1. That means what? That means whenever router here prefixes to their EBGP neighbor, to their EBGP neighbor, it always modify next hop IP. It always modify next hop IP address. 1 minute. Means in this case, all the routers have route in the routing table. All the routers, all the prefixes are valid as well as best. So all the routers are going to install it in their routing table. Here you don't need to remember anything. This is exactly similar like IGP protocol, OSPF or EBGP. Yes or no? Then why I discuss this rule here? To make you understand the next hop rule in case of IBGP. What I am saying, the router never modify the next hop address while advertising prefixes to their IBGP neighbor. To their IBGP neighbor. So see what will happen now. Next hop rule for IBGP. Again, I have same scenario. 3 routers are there. R1, R2, R. These all things, whatever issues we have seen till now, I have one issue for IBGP neighbor. Like if 3 routers are directly connected and if we are running same ES number on all the router, then there will be issue. Third router will not receive prefixes which are connected to router number 1. Right? So we'll see the solution of that issue. And here I am going to show you the another issue. In case of EBGP, I don't have any issue. For the next hop also and for the loop avoidance also. Okay. Now, here IP address again 12.1. Here IP address 12.2. Here IP address 12.2. Here IP address 12.3. Again here I have subnet 10.1.1.0/20. So first of all, R1 is going to, and on all the router this time I am running same ES number 10, 10 and 10. This is IBGP. Router 1 is going to install 10.1.1.0/24 in their routing table. Next hop IP 0.0.0. Self advertise fix, and it is valid as well as best. Correct? Now R1 is going to advertise it to R2. R2 on router number 2. When R1 will advertise to R2, what will be the source address in the update? 12.1. So R2 will, for R2 this prefix is going to be valid as well as best 10.1.1.0/24, and next hop IP address 12.1.1.1 because 12.1 is reachable from router number 2, and this is the source in the update message. But this time guys, when R2 is going to advertise this submit to router number 3, it will not change the next hop address, source address. Source address in the update message is going to be same 12.1. So R3 is going to install this prefix 10.1.1.0/24 in the routing table with next hop or 12.1.1.1. So can this prefix valid and best?
No, sir.
Because 12.1 is not reachable from router number 3.
R3.
So router number 3 is not going to install it in their
Routing table.
routing table. R3 is not going to install it in their routing table. If you want to see here, I can show you. Now capturing is not. Stop it. Lucky one and let me connect one. Here I have one LAN 10.1.1.0/20. and let me configure the scenario. This time I'm going to configure IBGP. So let me say interface loopback 1 IP address, or before that OSPF is saying no router OSPF 1, no interface loopback 1, no interface loopback 10. I have removed interface loopback 1 IP address 10.1.1.1.255.255.255.0 exit no router BGP AS number 100. From router number 2 also no interface loopback 1, no router OSPF 1, and no router BGP. Great. Go to router number 3, and here simply I'm going to configure interface F0/0 IP no cert IP address 23.1.1.3 255.255.255.0. On router number 2 also I have to configure interface F1/0 cert and IP address 23.1.1.255.255.255. Now let me configure IBGP here. You can do one more thing. You can start capturing between both the link. Capturing between router 1 and router 2. And I can start capturing between router 2. Show you the source address in the update message. That's it. No any other purpose to start the capturing. Now let me configure the BGP from router number 1. Router BGP AS number 100. I am going to configure same AS 100 on all the router. Neighbor 12.1.1.2 and remote AS is 100. Remote AS is 100. On router number 2, router BGP AS number 100, neighbor 12.1.1.1, remote AS is 100. And one more neighbor is there, neighbor 23.1.1.3, remote AS is. Go to router number 3, router BGP AS number 100 and neighbor 23.1.1.2, remote AS is. On router number 1 you can see I have neighborship. On router number 2 you can see there are 2 neighbor. Correct? We can verify it. So IP summary. 2 neighbor are there. Both are up. On router number 3. So IP summary. Done. And on router number 1. So IP summary. We have neighborship. All are IBGP neighbor. Correct? Here is the capturing. R1 and R2. Now let me do one thing. On router number 1 I am going to advertise this 10 subnet. Interface loopback 1 IP address 10.1.1.1 255.255.255.0 exit router BGP number 100 and network 10.1.1.0 mask 255.255.255. Done guys. Enter.
Sir, on R1, can you show me the IP route towards the
Yeah,
23 network?
showing you just source 12.1 destination 12.2. Here in the update message source, where is update message? R3 is sending source 12.
सर फिल्टर कर लीजिए ना TCP डॉट पोर्ट करके
23.2 and 23.3 source R2 and destination. But when you will open this update message, see in the update, in this update message, another update Okay, directly I can show you here in the code. See on router number 1, so IP BGP. Guys, prefix is valid as well as best, and next hop is 0.0. So it will advertise to router 2, so IP BGP. Here also this prefix is valid as well as best. Next hop IP address is 12.1.1.1, so it is going to install it in routing table. So IP dot BGP done. But on router number 3, so IP BGP. What is happening here? Why router 2 is not advertising? Can submit to router number 3. Router 2.1 have advertised this to router number 2, but router 2 is not advertising to R3. This is the reason why we are not able to find the update message over here in this capturing. Why? What is the reason? Is loop avoidance of IBGP na?
Yes, sir. Because it is receiving from the
Yes,
IBGP peers.
R2 is receiving from IBGP, so it will not advertise to other IBGP. This is the reason. This is the reason why here I don't have and subnet. So later I am going to teach you the route reflector and those things, like how to break the loop avoidance mechanism. For now, on router number 2, just I am going to run one command, router BGP 100 to break the rule, and I am saying neighbor 23.1.1.3 and route reflector, right? Forget about this command for now. Okay, later we'll see this. Right, so just I have break the speed horizon rule in, sorry, loop avoidance mechanism rule in case of IBGP. Now on R3, so IP. Now you can see R3, R2 is advertising prefix to R3, right? In the capturing also you can find the update message now. Here you can see this from dot. Here it is. Router 2 is sending to router 3. And which prefix?
Above one, network layer reachability information. NLRI, yes. So,
Prefix 10.1.1.0/20.
oh,
And in the attribute here you can see next hop IP address is what?
the same one from R1.
Same one, because it is advertising prefixes to the IBGP, so it will not modify the next hop. Because of that, this prefix is only valid, not best. Here you can see greater than symbol is not there. So will
Yes, sir.
R3 install it in routing table? So IP route BGP. No, you can see in BGP routing table I don't have any. It's
Sir, one question here. If we provide the to R3 static route to R1, so it will be best,
but this
correct?
IP address. Yes,
Yes,
if
yes,
this
sir.
IP
Yes.
address is reachable from R3, then it will install this prefix will become best.
Okay.
Sir, on R1, can you just do an IP route to 23.1.1.3?
How I will have 23 dot here?
Just wanted to check.
How you can have 23 network on router number 1? That is not directly connected network.
No, I just wanted to check.
This is very basic concept, right? At least you should know this. By default, routers install only connected network in their routing table. Done. So here on R3, guys, we have the issue. The routing table, route is not there. In the BGP table, prefix is only valid, not best. So this is next hop rule in case of IBGP. In case of IBGP, router never update next hop IP address. router
सर
never.
एक बार आप नेबरशिप नेबरशिप बोल रहे हो नेबर्स का स्टेट दिखा सकते हैं क्या?
कौन कौन से स्टेट होता है नेबर का?
पहले आइडियल एक बार आपने दिखाया था, आइडियल दिखाया था ना, सो आईपी बीजेपी है ना सर, 0
तो प्रीफिक्स है, रिसीव प्रीफिक्स,
स्टेट स्लैश प्रीफिक्स रिसीव्ड।
स्टेट यहाँ पे
ओके
रहना चाहिए आइडियल या
ओके
सर एस्टेब्लिश तो दिखाना चाहिए नहीं, बट
नहीं,
वो
अगर नहीं
वो
दिखाता
डाउन
है मतलब एस्टैब्लिश है।
ओ हाँ सर, ऐसा होता है कि डाउन जाने के बाद एस्टेब्लिश शो करता है दोबारा अगर
नहीं,
टीसीपी कनेक्शन बनता है
एस्टैब्लिश
तो?
नहीं दिखाएगा यहाँ पे, वो तो टीसीपी कनेक्शन था, सो टीसीपी ब्रीफ।
ब्रीफ, ओके ओके ओके, गॉट इट। थैंक यू सर।
So here what we can do, either later we'll see the another option also. I can tell to router 2 also to update the next hop address by creating route map. But for now, just I am going to add one route for 12. Submit here. 150 IP route. Even I am not talking on about the solution, guys. This is just the rule of next hop in case of IBGP. So you need to keep it in mind that in case of IBGP, router not modify the next hop address. Router not modify the next hop address. In case of EBGP, router always modify the next hop address. Right? So these 4 rules you need to keep in mind. 1, loop avoidance in case of IBGP, loop avoidance in case of EBGP. Next hop in case of IBGP, next hop in case of EBGP. Okay. And here we'll talk about solution later. For now, I'm just adding one route 12.1.1.1 255 255 exit interface f1/0 and next hop IP address this one, right? So on this next hop, so IP BGP, on this next hop will become reachable. This prefix will become what? Now you can see this prefix is, and so IP route BGP, now it have installed it in. But this is not the actual web, because in the real time you will never configure WAN like route for the WAN subnet, or you will never advertise WAN link in the routing protocol. So we'll see the exact method, what method we are using in the industry. Okay, but for now keep in mind the rules, all the. Now let's stop the capturing here. Update message, you the attribute, attribute. So for the first time, router 1 will advertise prefix to their IBGP with next hop IP address with exit interface IP address of these devices. And let me create one lab for that. You will configure by here. You can connect one switch. You will not able to make communication, then I will tell you the process the next, but at least R1, R2, R3, R4, R5 also 4, 5. Same lab you need to get in your NS3, or I will share this lab directly. You can import. Subnet between router is going to be exactly same like between router 3 and router 4. 34 subnet between router 4 and router 5. 45. Here also you can connect. Whatever rule we have discussed here, you can cover all those rules. Picking the my subnet, let's say 50.1.1. 50.1.1. And you need to make reachability between 10.1.1.0 and 50.1.1.0. But the interesting thing is, here for an example, I am running PES number. My BGPS number 100, and this is PS number. So definitely by default, after enabling the BGP, there will be no reachability. BGP 100. Right. So after configuring BGP on all the router, you will see 10.1.1.0 is not able to communicate with 50.1.1. And then you can configure the route. You can make all the prefixes as a best in the BGP table, so that router can install it in routing table, and then you can try to make reachability. Otherwise, in the next class, I am going to tell you what is the actual method to configure this scenario. Here we have to learn route reflector concept, which is so important topic of BGP, right? So topic for tomorrow is going to be route reflector. Remind me when we'll start next class. Route reflector. Okay. That's all for today. Continue. Now, if anyone have question, please ask. Any question from these all topics, today's topic and yesterday topic?
Sorry.
All clear?
Yes, sir.
Yeah.
All clear.
If this lab for reflector.
सर नेटवर्क क्या है R4 R5 के बीच में, वो तो मेंशन कर दीजिए.
Router R4 और R5 के 45.
ओके.
अब कोई भी नेटवर्क यूज कर लो, आपको अगर अलग यूज करना है तो can use any subnet between the router. That's not matter. What I tell you, my task is to make reachability between these two. And you need to configure BGP ES number 200 on router 2, 3, 4, 5 and BGP ES number 100 on router number 1. So when router 1 is going to advertise this 10 subnet to router number 2, it will update the next hop IP address. Next hop IP is going to be 12.1. It is going to be 12.1. Router for router number 2, it is going to be best prefix. Best and valid, so router 2 will install it in routing table. But when router 2 will advertise it to router number 3, will not modify the next hop. So next hop will be 12.1 only here, because router 2 is advertising to their IBGP. So here you have to configure one route for 12 subnet in the same way on router number 4, on router number 5. Okay.
Sir, just general, small doubt. Is it possible directly to make a route advertising to R1 to R5 by configuring a loopback address?
Yeah, that is, why not? That is possible. But here what I told you, you need to form directly connected neighborship. Between all the router, you should have neighborship. But you can configure direct neighborship between router 1 and router 5. Both types of neighbor, IBGP or EBGP.
Okay. Sir, one more question can I ask apart from this?
Yes, you.
Yesterday you have posted one network interview question on the PM networking.
YouTube channel?
Between, yes, your YouTube channel. to make between the router and multi-layer switch.
Okay, got it.
You have
Understood.
configured as the trunk. Yeah. I tried this one. Yeah, I got the answer. But the thing is, I couldn't able to find the MAC address of the MAC address entry of router one in the multi-layer switch. It's not possible. It's not succeed. But for you, it's showing the MAC address table entry. Can you please
I
this
think
reason
there
you
was
can
one
post in the
router
yes
and one multi-layer switch was there. This switch
yes
was
exactly
configured as trunk.
trunk
Right?
VLAN
And here
10
I had one SVI for VLAN 10
yes
with IP, let's say 10.1.1.2.
1.2 yeah
Okay.
2
Here
like
10.1.1.1.
10.1.1
So tell me if I am going to ping 10.1.1.1 from the switch, what will happen?
it will not work.
First switch is going to check routing table.
Yes,
Route is directly connected on which interface? On VLAN
VLAN 10
10 interface. On VLAN 10 interface. So it will forward traffic from the trunk link
with the tag value.
with the tag value of VLAN
Yeah,
10. And then router is going to receive it at layer 1,
layer
then at
3 port.
layer 2. Okay, this is layer 3 port, but router will first receive traffic at which layer? At physical layer.
And
Convert
then layer
bits
2
into frame, then it will hand over to layer 2. At layer 2, which message it is? It is ARP request message.
ARP yes ARP
right?
request message.
So can this router process this traffic at layer 2?
No, it cannot. It has a tag value.
Which will never resolve the MAC address of router 1 then. Yes, that is
But for
true.
yeah
That's true. In your
yes sir.
case, you are saying the switch is not able to resolve the MAC address. It will not able to resolve the MAC address, na?
Yes, sir, you are right. But you have you told on that video there is an only interesting switch is learning the MAC address, but router it's not able to learn the MAC address. This interesting thing you have to find the answer. You told it like this. That's why I tried much times, but I cannot able to find the MAC
Then
address.
I have to go through the video once.
You told that very interesting thing. Multi-layer switch it's learning the MAC address from R1. But anyway, communication is not happen on your video also. But you asked this question tricky. That's why I asked.
Okay. So you tried it in the EVNG,
No, sir, I don't have packet tracer only.
the packet trace, and your
Yeah.
multi-layer switch is not learning the MAC address. But I
Yes, sir.
think multi-layer switch will not learn the MAC address.
But for you to learn the MAC address, you showed on the video also. You told it's very interesting thing. Why it's learning? Or you have to find the question answer.
So I think this interface was SVI. This interface was configured uh, as for like I think encapsulation protocol is also running on this port on the router interface. I have not configured IP on F0/0. I think I have configured IP on F0/0.10 on sub interface.
But yes, sir, you are right, sir. But before going to do these steps, it has learned the MAC address. That's why I confused much time.
Okay, I will go through the video once. Okay, I will tell you then tomorrow.
Okay, sir. Okay, sir.
Sir, you promised the video for EBNG setup.
So, brother, video is already available on the YouTube. I checked. Everything was working fine. So that's why I have not make the video. Video is already available. Then what is the logic of making again the same video?
I think Rahul told that he was facing some issues, and you told that I think some things got updated and a new video should be made about
So
that.
I
I
have
don't know
already
some.
shared the new video, na? The updated video in the group.
No, sir, it was not shared in our group, sir.
In which group you?
November.
Sharing? That okay. go through this video.